Of you, I welcome you all on this wonderful platform that is BYJU'S exam prep. And as you know, we are coming up with ISRO PYQs, and we have already seen the ISRO PYQs. Yes, just wait, guys, just wait. We have already solved the PYQs of ISRO of year 2020, 2019, 2017, and 2016. And now today is going to be ISRO 2015 paper. Yes, today is going to be ISRO 2015 paper. Yes, so guys, please tell me, am I properly audible and visible to all of you? Then we are starting the session. Okay, then we are starting the session. Fine, guys. So, guys, this is some detail about me. And as we are today going to discuss the paper, entire mechanical team will be doing that. So I will be taking the question of strength of materials, machine design and production. Okay, for these three topics I will be taking care of. You can also say in production material science is also there, so that will also be covered simultaneously. So we are starting, guys. Before we start, 2 to 3 important announcements are there. That one is related to the 11th June, that is tomorrow 12 p.m. You are going to have a national scholarship test where you can get up to 90% scholarship in the GATE preparation program. And guys, after that, there is a workshop on 13th of June at 7:30 p.m. will be taken by Abhinav sir. 7 key factors that transforms every student to the GATE topper. Then after that, my dear, tomorrow we are going to have from 10 a.m. tomorrow, sharp 10 a.m. Me and Abhinav sir would be taking this strength of material marathon class, where we will be going for the last 5 years PYQs. Okay, so that is what we are going to do. And guys, this is when we are going to start ISRO practice course, and we are starting it from Monday onwards. We will be starting with strength of material. So till now we were doing only PYQs. Now we will be coming up with the new questions. Okay, so we are starting, guys, with the very first question. So initially some questions are from strength of material, then machine design, then production. Likewise, we are going to move further. Yes. Please tell me, am I properly audible and visible to all of you or not? Then we are starting the session. Yes, everybody, guys. Okay, so we are starting it. So this is the very first question, guys. The very first question is from strength of material and the chapter SFD BMD. Chapter SFD BMD. So this question is from strength of material, chapter SFD BMD. Yes, Vinod, very good. So Vinod have answered it B. So I would like to tell you the question is the point of contraflexion is a point where shear force changes the sign, bending moment changes the sign, bending moment is maximum and none of the above. So as Vinod have answered, yes, very good. GPA, very good. Arunita, very good. So all of you have answered the question as B. So my dear, as we already know that point of contraflexion is the point where we get bending moment is becoming 0 and changing the sign. So the answer is going to be B for this. Very good. I Rolex. Moving to the next question. So guys, this question is once again from strength of material and this is from torsion. Okay, you can see the statement. It is angle of twist is given, length is given, and the maximum shear stress is given. They have given you the value of G and you need to find out the radius. So I feel you guys are aware of the equation. T by J is equals to tau max by R is equals to G theta by L. So when we keep tau max, we are keeping R max. So here you need to find out R max. So we will be taking tau max upon R is equals to G theta upon L. So if something is to calculate, it is R. So we can write tau maximum into length upon G into theta. So that is what you need to do. Use this formula, find out the radius of the shaft. This is I feel very few questions are coming as numerical. Sir, where to study the topics for ISRO scientist exam or any book? Dear, as when we are talking about, there is no specific book is coming, but we are going to launch a course from Monday onward. Okay, so we are going to launch a course from Monday onwards. So if you are going to following us properly, we will be giving you the schedule of that, every day we will be having every alternate day we will be having the classes, and where we will be discussing the questions of separate subjects, and also the topics which are slightly deviated from the GATE syllabus, that also we are going to cover. And aptitude part also you will be having the classes. So for that you need to follow us on the regular basis. From Monday onwards, series is going to be starting on the same channel only. Okay. Arunita, I have given the answer as A for this question. What about others? Try to solve it. This is a question which will take some time, and very few questions are like that. Hardly 3 to 4 questions are there in the paper which are time taking. So when you give the real exam, you need to attempt that at the last, because time is limited in the paper. Okay. Yes. So GPA, please solve these questions. Like today, when you see all the type of question, you will have an idea about the different things which they are asking in the paper. So all these previous years paper are going to help you, because many times questions are repeated in ISRO as well. Like today, I will show you 4 questions repeated, which we have already discussed in the ISRO PYQs. The Ruto have given the right answer. 27 by pi is correct. First of all, you need to convert the theta. Theta is given as 1 degree. You can write it as pi by 180, and this is becoming radian. Whenever you put the theta value without sine, cos, tangent, you need to put in the radians only. So when you will put this value, the answer will be coming out to be 27 by pi. So D will be the right answer. Okay. Vinod, I feel here you have done some mistake. Answer is D for it. I have already solved it for you. Let me once again cross check. Okay. Because I have already done before starting, so that I can tell you the right answers. So yes, answer is D. Answer is D, no doubt D. D is the right answer. Okay. Official answer key also I have matched. Answer is D for this. Is it clear? Shall we move on, guys? Shall we move on, guys, to the next question? Next question is once again from strength of material. It is related to deflection, and it is also very easy question. Easy, I am saying it is actually repeated question of GATE. This is a repeated question of GATE. Repeated question from GATE. It have been asked in GATE, mechanical, civil, XE, all the branches. So here in this question, they are saying a frame of 2 arms of equal length shown in the figure. The flexural rigidity of each arm. The frame is EI. The vertical deflection at the point of application of the load is. So you need to find out the deflection at A. So you know that if this is A, this is B, and this is C. If you want to find out deflection at A, you just need to partially differentiate the total strain energy with respect to P. That will give you the deflection at point A. Okay, in the direction of load. This is what you need to do. Very good, Jamin, Roshan. Okay. So Jamin and Roshan, are you giving the answer for this question or previous one? Are you giving the answer to this question or previous one? So when you will be doing this, U is nothing but the strain energy of AB plus BC. AB plus BC. Great, great, Jamin. So AB plus BC. If you see this AB part, you are going to have this shear force. So when you will be taking the section XX, you can write U of AB is equals to integration 0 to L mxx square dx upon 2EI. So you know that here mxx is nothing but minus px. Similarly, if you want to see the effect on BC, you will make one force here, other force here, and this will be making a couple. So for this beam, we are going to have a bending moment and axial force. You know, we find out energy only due to moments. So U of BC will be coming out to be once again mxx square dx upon 2EI integration 0 to L. So when you will be going and add their U, and after that Pagel word, yes, Pagel word, today you are slightly late. So answer for this, everybody is saying C. Everybody is saying C, as they are asking what? They are asking you the deflection. Yes, everybody have done it C. There are some questions which are coming. Okay. There are some questions which are coming as it is. Okay. Fine, guys. Okay. Shall we move further, guys? Are we ready? So for this question, are we getting B or C? Please tell me. Are we getting B or C? Please tell me. Look at it carefully and then answer. B or C? B or C? When you will be finding out the strain energy of this, what will be getting? What you will be getting? Px ka square. So you will be having P square L cube upon 6Ci. That you will be getting this energy. Is it clear? And when you will be solving this, you know that this is going to be the case, and you will be putting the value as it is, P into L. So we will be having P square L cube upon 2EI. So when you will be adding these two, P square L cube, you can write it 3 here, 3 into 3. So 3 plus 1 is 4. It will be 4 P square L cube upon 6Ci. So my dear, okay, I feel C is the right answer. C is the right answer. Okay? Is it clear for everyone? Moving to the next question from thin cylinder. Once again, strength of material. Thin cylinders. This is asking a thin cylinder shell of diameter D, length L and thickness T is subjected to an internal pressure. The ratio of the longitudinal strain to the hoop strain. Longitudinal strain to the hoop strain. So you know we are having longitudinal by hoop. Okay, longitudinal is PD by 4TE. What you will be getting? 2 minus mu or 1 minus 2 mu. Is it correct? Or have I written opposite? Okay, Roshan have given the answer to be B. Pajalward have given the answer to be B. Have I written the correct or wrong? Is it correct? When you are going to find out the circumferential stress, you are writing sigma C by E minus mu times sigma longitudinal by E. If you are going to say that, we are going to have sigma, okay, this will be, I feel, sigma C is PD by 2TE, PD by 2TE minus mu time PD by 4TE. So when you will be having, this is PD by 4TE, it is going to be 2 minus mu. So whatever I have written is opposite. This is circumferential, this is longitudinal. They have asked the opposite ratio. They have asked about longitudinal and circumferential. The ratio of longitudinal and circumferential. So it is 1 minus 2 mu upon 2 minus mu. Mu can also be kept as 1 upon m. So you will be having 1 minus 2 upon m divided by 2 minus 1 upon m. So when you will be going for that, you will be getting m minus 2 by 2m minus 1. I feel answer will be A. Yes. Naruto, Jamin, Arunita, Pajalward, Roshan. Is it clear? Are you getting it? This is the ratio of circumferential to longitudinal. But we need to answer the longitudinal to the circumferential. And you know Poisson ratio is mu. So you can write mu is equals to 1 upon m. Go to your mistake or not, please tell me that. Go to your mistake or not, please tell me that. Go to your mistake or not, please tell me that. Everybody. Yes, so answer for this is going to be A, not B. Is it clear for everyone? Shall we move on, guys? Don't worry, dear. Here we are only to correct ourselves only. We can make mistake here, but we need not to make mistake in the exam. Is it clear for everyone? Now this question is also a repeated question. This is already asked in GATE and ESC both. This is repeated question of both GATE and ESC. Yes, only one change they have done. They have increased the length to 2L. In original question length was L. So do not copy and paste this time, Jamin. Jamin, you got the mistake or not? Please tell me that. Previous question. Please answer, guys. How I would get to know are you getting it or not? Very good. So this is the case. We are going to have a simply supported beam, supports A and B. So here the reaction RA will be coming, here the reaction RB will be coming. We are also having the force here. So first of all, we will be shifting the effect of force onto the beam. We will apply one force downward, other is upward. Okay, so you know this and this will be making a couple like this. Okay, so we now have a simply supported beam like this. This is RA, support reaction. This is RB, support reaction. At the center, we are going to have a force P, and then we are having a moment P into A. You need to tell the maximum bending moment. Why it's in terms of M, why not in terms of Poisson ratio? Jamin, actually Poisson ratio is also defined as 1 upon M. Okay. So like whenever someone is going to give something, he defines in his own way. Like there are some researchers who were living in the country where FPS system was used. Some were using MK system, some was using SI system. So based on their system, they are going to define the things accordingly. Their notifications are like in material science, you study alpha, beta, gamma. They are the Greek words. So that depends that who have given the things. Poisson ratio is always defined by either mu or 1 upon M. So answer for this is okay. So answer given by Pagel and Roshan is B. Pagel and Roshan is B. Okay, we will see that. First of all, we will find out RA and RB. So RA will be coming out to be this total length is 2L, mind it, total length is 2L. So you will be having P by 2, 50%, then minus PA by 2L. This is RA. What is RB? P by 2 plus PA by 2L. When you will be going for bending moment diagram of this, it is very easy. Many times we have seen this. It will be going like this. Then there is a jump due to this, and then it is like this. Okay. So this value will be the maximum bending moment. If you want to find out this value, you can do RA into L. RA into L will be this value. Plus you need to add PA. So maximum bending moment will be RA into L plus AP. So RA we are going to have P by 2. P by 2 minus PA by 2L into L plus AP. So when you will be going for this, you will be having PL by 2. PL by 2 minus PA by 2 plus PA. So it is PL by 2 plus PA by 2. 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 Is it clear? Yes. So are we getting the answer? What is the answer for this one? What is the answer for this one? Is it C? This is PA by 2L. PA by 2L. Okay. Multiply with 1 by 2. Where I need to multiply with 1 by 2? Dear, this is the load P. Load P is divided equally into 2 P by 2, P by 2. Okay. Then this is the P into A. So PA by 2L. PA by 2L will be subtracted here, added here. Why? Because direction of this is going to be like this. Same as that of RA. So here it will be subtracting, here it will be addition. Then my dear, I have multiplied it with L. Why L? Because this half length is going to be L. So when you will be multiplying it with L, you will be having PL by 2 minus PA by 2L. So you will be getting PL by 2 minus PA by 2 because LL will get cancelled out. Then you will be having plus of AP. Yes, so answer is going to be B. Okay. Jamin, what you said I didn't get, but multiple with 1 by 2 I didn't get. I feel answer will be B for this. PL by 2 plus AP by 2. Is it clear for everyone? Please tell me that. Okay, very good. Moving to the next question, guys. Now we are coming up with column chapter. This question is from column. This time I will not help you. I need answer from your end. It is easy question. Very good Karan, very good Roshan, very good Pagel word. So answer for this question. A vertical column has two moments of inertia, Ixx, Iyy. The column will tend to buckle in the direction of the option A, axial load, option B, perpendicular to the axis of load, option C, maximum moment of inertia, option D, minimum moment of inertia. Very good. Arunita, Pejal Word, Shahid, Naruto, Vinod, Jamin. Answer is D, because you define Euler's buckling load as pi square EI minimum upon LE square. So my dear, always the buckling will happen for minimum I, because where I will be minimum, there buckling will happen because load will be lesser there. So D is the right answer. So guys, next is machine design theory of failure. Machine design theory of failure. Machine design theory of failure. Tell me this answer. This is question number 7 going on. Question number 7 going on. Yes. Naruto is saying A, Roshan A, Vinod A, Abdul A, Pejal Word A, Shahid A, Karan A, Jamin A. Very good. MPST. Here I am telling you, if they say material is brittle, you need to decide without any thinking. You will say MPST. When they say ductile, then you know there are two options. If nothing is mentioned, MSST. If they say ductile material and we need the economical theory, then my dear, economical is MDET. But that is rare combination, have never been asked. So either this or this have been asked. Moving further. Wonderful guys. This is once again repeated question of gate mechanical. That's why I said when you are going for mechanical engineering questions for gate, or you are going for questions of ESC, many questions will be repeated. I feel everybody got this question. This question is a repeated question of some and very famous question it is. So this is from bending. They have applied a load F here and they are asking the stress at this point P. So for that I need to shift this load on the longitudinal axis of this member. So we will be applying one force downward, other force upward. This and this will be creating a moment like this. So finally we are having a member now like this. And we have two things. One is P, other is, this is F actually. F into L minus B. This is the moment. And you need to find out the stress at this point. Okay, this is the question. I feel here also many students have remembered. Yes, try to solve it guys. Because in paper they will change something and you will be thinking what happened. First of all, it is a square geometry of 2B side. So you know that we will be having at this P, this load will give us tensile only like this. And for bending, you can see it is like this. So we just need to add these two values. So if you want to write down the stress at point P, you will write force by area plus M upon ZNA. You know force is F. Area is 2B ka whole square. Then bending moment is F into L minus B. Very good, Jamin. F into L minus B. And Z is A cube by 6. So 2B ka cube by 6. When you will be solving this, answer will be coming out to be D. Here you have F by 4B square plus F into L minus B divided by 2 ki cube is 8. It is 6, 8 B cube. So it is 4, it is 3. Okay, so we can write in the denominator 4B cube. You would be having here F into B plus F into 3L minus 3B. So solving you will get D option. Jamin have given the right answer for this question. Shahid also. Naruto also. but I feel Vinod and Pejal have made the mistake. Got it? Got it, Pejal and Vinod? Please tell me that. Wonderful, guys. Moving to the next question. Next is from, once again, SFD BMD. Actually, it is from SFD BMD plus bending, because they are asking you the bending stresses. They're asking you the maximum magnitude of bending stress. We know that when we are talking about the maximum bending, it will be M upon ZNA. So when it is maximum, M should be maximum. So using SFD BMD, you need to find out the maximum bending moment. If you will get the maximum bending moment for this, you will get the answer. And for that, you need to write the bending moment equation. For that, you need to find out support reaction. First, find out RA and RC. First, find out RA and RC. Then, my dear, after finding out this, you can go for shear force equation, bending moment equation, where shear force becoming zero, bending moment will be maximum. So that is how you need to go for. If you are going with equations, if you are going with the BMD diagram, then you must be aware from BC region, you would be having a parabola. I will be showing you diagram as well. But first you find out the value of RA and RB. First find out the value of RA and RB. This is the first task. So you can see in this paper, some questions are lengthy, like 2020 paper. So in some of the question, you will find some question like that. But otherwise, all questions are theoretical. Yes, solve it, guys. Solve it, guys. Solve it, solve it, solve it. After me, Suraj sir and Chandra sir will come for thermal, heat transfer, fluid mechanics, RAC, IC engine, power plant, industrial engineering, engineering mechanics, theory of machines. Okay. All questions would be covered. In this paper, major weightage was for SOM MD production. For these three topics, I have more than 35 questions. Okay. So that is how you can relate. So in some of the paper, weightage is different. In others, weightage is different. So you can see this is 3000 Newton per meter and applicable for 2 meters. And you can assume that to be present at centroid. So at centroid, you can assume 6000 Newton. So that will be 1 meter distance from here, 3 meter distance from here. From that only we will get the values. This will be 4500. This will be 1500. Okay. So values will be coming like that. So we got the values very easily. Now if you want to write down the shear force equation, I am taking the section here. Taking the section here at a distance of x. You can write it as per the sign convention. To the left, upward, right, downward is positive. Left, downward, right, upward is negative. So right upward is negative. So I will write minus RC plus W into X. So it will be minus 4500 plus load is 3000 into X. From here you will get X is equals to 1.5 meters. It means the maximum bending moment will be coming somewhere here. Here we will be getting the maximum bending moment. Where? At 1.5 meters. Now my dear, if you want to know, very good, very good. Jamin have given the answer, Pejal would have given the answer. And answer is correct as well. So when we are talking about the maximum bending moment equation will be, you know the sign convention, this is sagging, this is hogging. So this is creating sagging, so we will write RC into 1.5, sagging, minus W into 1.5 into 1.5 by 2. So you will be having RC value as 4500. 4500 into 1.5. Minus 3000 into 1.5 ka square by 2. Okay, here you will get the maximum value of bending moment. So once you get this, you need to put it there, and they have already mentioned the width to be B, height to be 100. So Z will be B D square by 6. After solving, the answer will be coming out to be 67.5. Everybody understood? Please tell me that. So this type of question you can have in GATE as well. So Jamin and Pejal have solved it. About others, Vinod, you got it. Shahid, you got it. Naruto, you got it. Please tell me that. Everybody, please tell me that. Then only I will move further. This was question number 9 for us. Question number 9 this was. Great. Yes, Shahid, this is very, that's why I said in ISRO paper you need to attempt these questions in the last, okay? Because in the paper, if you will be solving these questions in the starting, you may not be able to complete the paper and you may leave some easy questions. So that's why I always say when you are giving ISRO, in the very first reading, you tick only those questions which you already know by looking at the question. And then second attempt should be for those questions which are using less calculation, but you know how to do this. Then third attempt should be for this type of question. Third attempt means third time when you will be reading the paper. So this is PL cube by 3EI is the deflection under the load P for a cantilever beam. The strain energy due to bending is. So he is saying that if we are having a load P like this. So because of this, you know that deflection is PL cube upon 3EI. Then what is strain energy? I already told you strain energy is half into force into deflection. Then you already know half, you already know P, you already know deflection. Just apply the formula, get the answer. What would be the right answer? Wonderful. Everyone have already given the right answer B. P square L cube upon 6CI. Moving to the further, now material science questions came into picture. There is one good thing about ISRO that they put question in continuity, like all SOM questions are kept together. Now you are having the material science questions. Material science weightage is equals to the weightage of production. Sir, as per notification, single mark question will be there. Dear, it doesn't matter about single marks. It matters about the time. Previously, they were giving us for 80 question, you were getting the time of 90 minutes. Now you are getting 95 question and a time of 120 minutes. By looking at that, what you can understand, don't go by weightage. Previously, they were multiplying it with 3. Now they are multiplying it with 1 only. That is the difference. So that is just they are trying to make it complete 100, nothing more than that. But they will give you question as per the time, not as per the marks. Okay, are you getting it? So if you see this now, there are more chances that more 1 to 2 questions you can find like that. Okay, so this is very easy question. I told you this is a repeated question. Average number of atoms, effective number of atoms is average number of atoms. So average number of atoms for simple cubic, body center cubic, face center cubic and HCP. Simple cubic, BCC, FCC, HCP. Okay, dear, I would also like to tell you, all of you, when we are coming up with the this launch session of this ISRO practice series, try to be available. I will tell you there that if you want the sources to revise, how to go for it. Because in this channel, everything is available. You just need to follow my words. Okay. If you will go by that, your ISRO preparation will be automatically done. So for this question, you need to answer. For simple cubic, average number of atoms is 1. For body center, it is 2. For FCC, it is 3. It is 4. For HCP, it is. For HCP, it is. Yes, 3, 6. Is it clear? So answer would be 1 to 4 because they have asked only up to FCC. Wonderful, guys. So B is the right answer. This is once again from material science ESC paper 1 part. Because ESC paper 1 we study about the thermosetting plastics and all. If you are prepared for ESC paper 1, there this part is coming. Thermosetting plastic have in general. molecular chains that slip past one. B, a ceramic, since all ceramic are glass and glass is a kind of ceramic. Have a monolithic, have no long range crystal lattice structure. Janil have given the right answer. Jamin, answer is D, because they do not have the crystalline structure. They are plastics. They do not have the crystalline structure. Crystalline structure have 3D long range periodicity kind of things. Very good, Vinod. Answer is D for it. So this type of question now you can remember because it will be repeated many times. They are not asking all the time new questions. Some are repeated only. Moving to the next question, guys. Silicon steel is widely used in. Silicon steel is widely used in. This is the repeated question in many examination. Repeated question in many examination. Okay, repeated question in many examination. Like JE, RBUNL JE. Okay, tell me the answer for this. Very good, Jamin. The answer is C for it. Whenever they are asking this question in JE, in place of writing electrical industry, they are putting the names of application like transistor, diode and all those things. So the answer is going to be C for this. If you don't know, from now onward you can remember because they are repeated question. Moving to, I already told you, they go for in continuity. Now all the questions are for production and material science in continuity. Which bond gives the softest bond? Which bond gives the softest bond? This is related to the grinding wheel. When you are going for grinding wheel, we are going for some type of bondings. Okay. So which bond gives the softest bond? Silicate, shellac, vitrified, all of equal strength. Vinod is saying the answer to be B, shellac. What about others? I know here you have less idea. I know that. Okay. So first of all, I would like to tell you that vitrified bond is used for more than 75% of grinding wheels. So if someone asks about most popular or mostly used, it is vitrified. But my dear, weakest is silicate bond. Answer is A for this. Weakest is silicate bond. Okay. Majorly used is this one, vitrified. Moving further. This is from material science, and eutectoid steel consists of pearlite, austenite, pearlite ferrite and pearlite cementite. Eutectoid steel. Eutectoid steel. Eutectoid steel. Yes. It is having actually alpha ferrite plus cementite. Together it is said to be pearlite. Iron carbon diagram. Answer is A. Answer is A. Array, pearlite itself is ferrite plus Fe3C. Are you getting it? Pearlite itself is ferrite plus cementite. Pearlite is a mixture. I told that in great detail in the marathon sessions also. This is a solid solution. This is a compound. The answer will be A, wholly pearlite. Got it, Vinod? Next question is German silver. This is from 11th class chemistry they have asked. This is not in any of the subject. This is from 11th class chemistry. And why this is given? Because in this name silver comes, but in reality this is made up of 3 constituents in which silver is absent. Okay, so that is the beauty of this question. So when you are going to talk about this, it is made up of copper plus zinc plus nickel. There is no silver in this. Yes, so that's why they are asking this type of question. Because the name consists silver, but constituents do not. So that is why this is 11th class chemistry question. This is have nothing to do with our BTech syllabus. So some of these questions are coming. 1 to 2, but they are new for everyone. Moving to the next one. This is from casting now. Casting. They are saying when you are going to add coal dust, it will improve which property? It will improve which property? Yes, Shahid, Jamin, Pejal. Tell me the answer for this and do like and share the session, guys. Okay, Pejal is saying the answer to be B. What about others? Neeraj is saying A. Jamin, answer is B. It improves surface finish. Coal dust improves surface finish. Moving to the next. Slush casting process is used to produce hollow casting, intricate, large size, thin walled. Slush casting is used to produce. Slush casting is used to produce. Karan is saying B. Pejal word A. Neeraj C. Jamin A. Answer is A. So my dear, whenever we are talking about slush casting, in this what you are going to do? You are going to make a cavity like this. In this cavity, molten metal is kept. Then it is allowed for partial solidification. And when desired thickness is obtained, I didn't say thin thickness, I said desired thickness is obtained, rest molten metal is taken out. So whatever you got, that casting is hollow. It may be thin or thick, but it will be hollow. So answer could be either D or A, but the right answer is A because it can be of thick wall also. So this is used, and in this what we are doing? Partial solidification. Very good, Vinod. Moving to the next question, guys. This is once again a question of gate type. And this is from casting. Riser design. Chivorinov's law. Solidification time is directly proportional to V by SA ka whole square. So you need to find out the solidification time for sphere to cube. Sphere to cube. So we can write volume of sphere is 4 by 3 pi r cube. Surface area is 4 pi r square. Ka square. For cube it is 6a cube by, a cube by 6a square. Ka square. You need to find out this ratio with the given conditions. Hint is in front of you. Calculate it. This type of question you will be attempting in the last because they need more calculations. Solve it, guys. From my side, this question is question number 19. Question number 19. Okay, Jamin is saying B. And B is the right answer. Very good, Jamin. What about you, Vinod and Pejal word? Shahid, Karan, are you doing or not? Yes, everybody. Fine. Okay, Pejal. The answer is B. It is very calculative. 6 by pi is the correct answer. Very good. Moving further, guys. So you know this 4 will get cancelled out. Pi will get cancelled out. Okay. And this is 4 pi r square. This is 4 by 3 pi r cube. So when you will be solving, the answer will be coming like this. They have same surface area. Okay, they have already given the same surface area. So you can directly cancel out these two things. Okay. So you will be getting the answer to be 6 by pi. Okay. Metrology and inspection. Metrology and inspection. We are using plug gauges for taper bores, cylindrical bores, spherical holes, none of the above. You must be aware of that. Plug gauges are used for holes. You must be aware of plug gauges are used for holes and ring gauges are used for shaft. A and C में confusion है, दोनों ही गलत है फेजल, दोनों ही गलत है. Okay, answer is B for this. When you are having ring or plug gauges, ring is like this, na? This is ring. So ring is used for cylindrical. We are always studying only for cylindrical bores. Okay? So we are always studying only for cylindrical bores. So what we have studied is for cylindrical bores, means cylindrical holes only. So C, we have never studied about spherical. You must confuse between A and B. Okay? And you know taper we do not study, so we are going for cylindrical bores. Very good. Moving to the next question, guys. This is very easy. Gate का repeat question है ये. This is gate का PYQ. Very easy question. You just need to do I square RT. Heat generated is I square RT. This is a repeated question without any change in data. This is question number 21. Question number 21. Very good, Pejal. Solve it. So, we are going to solve all the question. I am having around 35. 35 question I will be solving, and rest 45 questions will be solved by Chandra sir and Suraj sir. Yes, but what they have asked, they have said that two plates, this much, this is current, time, resistance, heat generated. They have asked only heat generated. I square RT. What will be the answer? I square. A is correct. A is correct. This is welding. Once again, PYQ of gate. This is once again PYQ of gate. Very good, Naruto, Neeraj, Pejal and Vinod. Preheating before welding is done to prevent plate distortion, cold cracks, burn away oil grease, make the steel softer. This is question number 22. I am there with you till 35 questions. Then Suraj sir and Chandra sir will come. Vinod, Neeraj, Jamin, all are saying C is correct. Yes, it is PYQ, C is correct. So when we are going up with preheating, this is our target, because when we will go with this, the cooling rates of nearby area will reduce. Because of that, we will not be having any cold cracks. So when we are not having cold cracks, this is the purpose. But yes, we also get this and this as some other advantages, because whenever we go for preheating, always oil, grease, all those layers are also burnt out. So this is also correct, this is also correct, but purpose is this. So these are extra benefits we are getting. Yes. Moving further, guys, from metal cutting, question number 23. Metal cutting, very easy question. कोई बात नहीं, पेजल वर्ड, data is not important, exam is important. Solve this question. Okay, net हो गया. Okay, खत्म. So answer for this is, you know that if this is our cutting tool, okay, then my dear, you know, this is the velocity with respect to workpiece. This is cutting velocity. Along shear plane is the shear velocity. And chip is going to flow in this direction. That is chip flow velocity. Chip velocity, B is correct. Moving further. So as I said, questions are not difficult only. Some easy questions are also there. This is question number 24. From milling, you need to find out the table speed in mm per minute. We call it as feed only. It is Ft into Z into N. So you just need to multiply the number of teeths, 8. Feed per tooth, 0.1. The speed is 150. Very easy question. Very, very easy question. Okay. Jamin and Pagelward are saying answer to be A. So as I said, you need to go for these questions in the very first go. In the second go for the numericals, which are slightly difficult. And third go for very difficult. This is once again 3 times already we have done this. This is a repeated question on ultrasonic machining. The material removal rate would increase, decrease, increase, then decrease, and decrease, then increase. What would be the answer? This is question number 25. Yes. Vinod is saying C. Jamin and Naruto saying A. This time Vinod is correct. First increases, then decreases. First increases, then decreases. Okay, so when we are talking about ultrasonic machining, the material removal rate is first increases, then decreases. Why? Because when we are going for ultrasonic, we are going to produce vibrations actually. So whenever we are going for this, you know that we are applying some, you can say some abrasive particles which are acting like the cutting edges on this. So when you are going for the motion of this tool inside, and for machining purpose, when you are going like this, other cutting edges will also applying the mutual drag in between them. So because of that, they are less induced in cutting. So that is why what we are going to have initially MRR is more, then we are getting less MRR. The reason behind that is the mutual drag present between the cutting edges. Got it, everyone? So I have given the explanation as well. This is 26. I told you every time question is coming from the tool life. So you would be saying V1 T1 to the power n, V2 T2 to the power n. 10 hours is obtained when cutting speed is 63. So 63, 10 hours means 600 minutes is equals to, you can put it equals to C, that is 257.35, because it should always be in meter. Okay, I have kept the values opposite. You always have the units as per the requirement. V1 is 63. Okay, I have written it correct only. This is meter per minute. Tool life is 600 minutes. It is N. C is 257.35. This will give you the value of N. After that, apply this. You need to find out the T2. When the velocity is getting doubled. Jamming, not guessing. Actually, you need to attempt then only, but manual calculation will take time. It will give you approximate answer. It is not guessing, it will be approximation. Guessing and approximation are different things. Okay, guessing and approximation are different. Like whenever you see the outside weather, you find that badal are there in the sky, then you say rain can come. It is approximation, it is not guess. Guess is like I am sitting in the room without looking at the outside, I say rain will come. That is guess. So we need to approximate, not guess. Okay. So dear, whenever we have this type of question, you can go like this. If you get the value of n, you can go like this, that V1 T1 to the power n is V2 T2 to the power n. You can get an idea that when velocity is becoming 2 times, what is the effect on the tool life? And dear, they are going to be difficult for everyone. It is not like only for you. So that is why cutoff is very less for mechanical. Civil paper of ISRO is coming very easy. Civil cutoff is going very high if you compare with yours. Like you will find the civil cutoff was 191 out of 234. Okay, 191, and yours was 121 or 119. So the difference is of 80-90 marks. Why? Because of the level of paper. Because no one is going to make these type of question without calci. Here you need to use logarithm. If you don't have calci, how you will solve it? You cannot. Okay. That's what I said, Jamin. For this, you need the log table at least. Otherwise, you cannot solve it without log table. Okay. So the answer for this will be coming out to be C, as Vinod have said. So dear, this type of question without calci you cannot do. If log table is given, then we can go for that. Because then you will be taking log on the both sides. Okay. Yes. Moving to the question number 27. This is a question from where? 3-to-1 method. It is jigs and fixtures. Jigs and fixtures. This type of question this time was asked in gate 23 as well. So it is there in gate 23 in more dangerous format. Okay. 3-to-1 method. 3-to-1 principle. Jamin is saying 9. Vinod is saying 6. So dear, I would like to tell you, whenever we are using 3-to-1, actually we are having a body like this. So we are providing 3 pins here. 1 pin here, 2nd pin here, and 3rd pin here. So like you can assume this to be the body. So I am applying one pin here, other pin here, 3rd pin here. So by providing these 3 pins, I am restricting this rotation, hai na? Okay, so these and this rotation are restricted and it cannot go in the negative x direction. Similarly, then we are going to apply 1 pin here, other pin here. That is not allowing this 3rd rotation and also restricting this translation. Okay. Similarly, we are going to apply 1 more pin here. Are you getting it? So when you are applying these 3 pins here, 1, 2 and 3, you are restricting this rotation clockwise, anti-clockwise. You are restricting this rotation clockwise, anti-clockwise, and restricting this translation. So 5 degrees of freedom are restricted by these 3 pins. Similarly, when you are applying these 2, you are restricting rotation in this and this direction. because one pin is this, other is this. It will not allow it to rotate like this. So 2 rotations and 1 translation. 3 degrees of freedom are restricted by this. 5 and 3, 8. When you apply this pin, it is stopping the motion in Z direction. Only 1 translation. So total 9 degrees of freedom are restricted by 3, 2 plus 1 pins. So answer is 9 for this, guys. Please tell me everybody got it or not. Neeraj. Very good. Karan, Vinod, got it or not? Still have doubt? Just feel it. This is the body. If you are having one pin here, other pin here, it will not allow this to rotate like this. Okay, so clockwise and anti-clockwise, total degree of freedom are 12. 3 translation, 3 rotation, nahi. 6 translation, 6 rotation. 1 rotation clockwise about x-axis, other is anti-clockwise about x-axis. So these 2 are restricted, these 2 are restricted. 4 rotation and 1 translation. 5 are restricted. When we are talking about this and this, it will not allow this rotation. It will not allow this translation. So total, my dear, 9 degrees of freedoms are restricted by these 6 pins. So 6 pins are restricting 9 degrees of freedom. Okay. So 6 pins, 9 degrees of freedom. Moving to next question. This is related to metal cutting. Question number 28. It is slightly lengthy question. So they have given you the rake angle alpha b 5 degree. Okay, they have also given the undeformed chip thickness, means uncut chip thickness 0.25, width of cut, shear strength 350, coefficient of friction, you need to find out FC and FT. FC and FT. I feel you would be aware of the shear force. First you need to find out shear force. From that you can find out FC and FT. Everybody remember the formulas for this. Try this and get it. Try this and get it. This is question number 28. After that we are left with 7 more questions from my side. Only this is the last numerical from my side. All other 7 questions are theoretical. Try to solve it. Try to solve it. So if you want hint, shear forces, shear stress, phi is the shear angle. You can apply this. This will give you the shear force. And after getting shear force, you can find out the cutting force, and that is nothing but Fs cos beta plus alpha minus. Okay, 1 second. First tell me this, then we will move further. First tell me this, then we will move further. Width of chip is given to us. T1 is given to us. Fs cos beta minus alpha cos phi plus beta minus alpha. Now you know that mu is tangent beta. Okay, try to solve it. I have given you the formulas. And this is FC tangent beta minus alpha. All the formulas are there in front of you. Very long calculation. This paper was very, very lengthy. This paper especially was very, very lengthy. So do like and share the session, guys. Questions are easy but with long calculations. Try to solve it. Angles are given: rake angle T1, B, shear stress beta. Find out. The answer is A. The answer is A. Dear, you are correct. Jamin, you are correct. But this is going to be the case with everybody now. Because whenever, like this year, UPSC civil services paper was very difficult. They have asked much beyond the syllabus. So this is for everyone. That's why the exam are relative. And that's why some have put the petition that they want to reduce the cutoff of CSAT from 33 to 23% because they have kept the minimum cutoff as well. So for ISRO, there is no minimum cutoff. So these type of question you shall try at the end only, because definitely this problem will happen here. But these type of questions you will find only in 3 to 4 papers of previous more than 15 years papers. So sometime only it happens, and when it happens, cutoff is very low. Okay, so no need to worry. Answer is A. So Jamin, answer is A. I feel anybody else have given this answer. A is the right answer. So FC will be coming out to be 1029.4 Newton and FT will be coming out to be 406.8 Newton. A is correct. Fine, very good. Very good, guys. So we have completed 28 questions. Now are you ready for the easy questions? Now we are having continuously easy questions. By just looking into that, you need to answer. Once again, metrology. This is the figure shows principle of traceability, interchangeability, matched fits or selective assembly. You can see this is hole tolerance, this is tolerance of shaft. So hole tolerance is given like this, shaft tolerance is given like this. Okay? Yes. So my dear, what would be the answer? Very good. The answer for this is selective assembly. Because you can see the tolerances are in the different ranges. If the tolerance of hole and tolerance of shaft are same, then we will say interchangeability. So here answer is going to be D. Very good. Question number 30. Moving to question number 31. A basic hole is one who have lower deviation 0, upper deviation 0, lower and upper deviation both are 0, none of the above. Basic hole is this one. Basic hole is this one, H type. What will be the answer? Yes, A will be the answer. Lower deviation is going to be 0. This is lower deviation, this is upper deviation. Okay? Yes. Moving to next question number 32. Generally in GATE, they are not asking this, the meaning of IT5. The meaning of IT5 is this or this. I feel this is the value of I, everybody would be knowing that. What would be the answer? This is the value of I, but IT5 indicates what? IT5 indicates what? Actually, IT, whatever you are talking about, this I, these terms are starting from IT6. After IT6 onwards, we are having the use of I. So the answer for this is going to be, this is question number 32. Yes. So answer for this is going to be what? It is B. 0.8 plus 0.002. Very good. B or A? B or A? Please check it. It is not B, it is A. 0.002 plus 0.8D. A is the right answer. Okay. A is the right answer. Pejal. A is the right answer. By C, who is saying C? Who is saying C? C is the value of I, fundamental tolerance unit. That is nothing have related to with IT5. Okay, that will be related to the number that is present from IT6 to IT10. Is it clear for everyone? Clear for everyone? Please tell. Moving to this question from machine design. Trapezoidal threads. Trapezoidal threads. Acme square buttress. Acme square buttress. Acme square buttress. The answer is Acme. Acme is the answer. Very good. Vinod, very good. Shall we move on further? Jamin, Pejal. Okay, next question. If the ratio of the diameter of rivet hole to the pitch, so rivet hole to the pitch is 0.25. What about tearing efficiency, which is given by 1 minus dH by P? So this is easy question as well. So you need to wait for the easy questions. What will be the answer? What will be the answer? Pejal, Jamin, Naruto. Answer is B, 75%. Moving to next question. This is once again machine design bearings. This is the repeated question. Life of bearing. So the life of a ball bearing for 10 kilonewton load is 8,000 hours. This is a repeated question. I have done it in the paper of 2018, 18 or 19. If the load is increased to 20, keeping all other conditions same, life will be. Yes, you need to tell L2. Tell me guys. Now after me, Suraj sir would be joining for his subject. They are mechanics, Tom, HMT and industrial. Yes, Jamin, Naruto, Vinod, everyone, answer will be 1000 hours because you will write 10 kilonewton into the life is 8,000 hours is equals to 20 L2. So as it is the life of ball bearing, it will be 1 by 3. It is also 1 by 3. So we will be going and making the cubes 0, 0 cancel out. So 8,000, 8. So L2 will be 1,000. So guys, from here I am leaving. Okay. Okay, one last question is there for me, 35th from welding. After this question, Suraj sir will come for other subjects. Then after Suraj sir, Chandrasekhar sir will come. So tell me the answer for this. Which one of the following is a solid state welding? Gas tungsten arc welding, resistance spot welding, friction welding or submerged arc welding? Yes, there will be a change of the type of question then. In this paper, mechanics questions were also lengthy. Okay, so you will see when Suraj sir will be coming. So guys, for you, we are sitting and solving complete paper one night before, and you are not that much enthusiastic and not coming for revising the paper. What would be the answer here? Friction welding. So my dear, gas tungsten arc welding is arc welding. This is resistance welding. This is arc welding. So only this is the solid state welding. Okay, from here I am leaving. Now Suraj sir will join us. So be ready for that. The question of mechanics, storm, industrial, heat and mass transfer.
Hello, very good afternoon, guys. Very good afternoon. Welcome back. So let's continue our discussion. The complete paper we need to cover up, and I'll be taking not more than half an hour or 40 minutes maximum. Then Chandra sir will be coming and join. Please do let me know before starting the session, is my audio and video all good, all perfect? Good afternoon, Vinod. Good afternoon. How are you all? I think you all are now energetic. You had the questions from production, you had the questions from strength of material, your material science and machine design, almost 36 questions. That means 50% of the syllabus is already being covered from those 4 subjects, right? So very good afternoon, all of you. All good, all good. Okay, fine. So let's begin. I won't be taking much time, right? So I hope so everyone has connected with me on my Telegram channel, I think, and I'll be sharing the PDF, the combined PDF on my Telegram channel, and this is my mail ID. You can note it down for any future reference. And as you know that 11th of June, your scholarship test will be conducted at 12 p.m. Do not wait till the last date. Register yourself today only. And on 13th June, Abhinav sir will be coming live at 7:30. 7 key factors. Okay, fine. So shall we continue our discussion? Yes. Okay, so let's continue our discussion after 4 subjects. So manufacturing, material science and machine design. Now let's go for mechanics questions. What kind of question is being expected? Okay, a shell is fired from a cannon with a speed of v at an angle of theta with the horizontal direction as shown in the figure. At the highest point in its path, it explodes into 2 pieces of equal masses. One of the pieces retraces its path to the cannon. The speed of the other piece immediately after the explosion. A very easy question. Very easy question. You have to apply the concept of conservation of momentum. Get the answer. Quickly, try this problem. There is a shell which is being fired from the cannon at an angle of theta with the horizontal. Like this is your angle theta with the horizontal. Now what happens when it is reaching the highest point? It is exploding. Now it is exploding into 2 equal masses. Okay, equal masses, right? Then what we have to do? The momentum before explosion at the base and the momentum at the explosion just after the explosion, we can equate and get the value of velocity. Chaliye quickly, is it 3v cos theta or 2v cos theta or 3 by 2v cos theta or root 3 by 2v cos theta? Very easy question. Yes. Now if I talk about the initial momentum, now initial momentum, we are having a mass m, right? I'm only going for that x direction. Okay, so v cos theta, so mv cos theta is the initial momentum that we are having. Now at the highest position, what will happen when this is moving in this pathway? At highest position, they have clearly mentioned that it explodes and one of the pieces retraces its path to a cannon. The speed of the other piece. Now definitely one piece is going in the backward direction. Let's say this is and this is equal to v cos theta, and let us say this is v dash, whose value we need to calculate, right? So can we say the momentum after explosion, just after explosion, what will be the momentum? It will be equal to m by 2 into v cos theta, because this is an opposite direction. I can say minus of v cos theta plus m by 2 into v dash. So equating the initial and final momentum, we can say mv cos theta is equal to m by 2 minus v cos theta plus m by 2 v dash. Solve it and tell me what's the value of v dash you are having. This is minus 1 plus 3m, 3 by 2, 2 into question, that is 3v cos theta. Are we getting 3v cos theta? After the explosion, the speed of the other piece will be exactly equal to 3v cos theta. And you won't believe this question they have taken up from a JE level problem. Okay, they have taken up this question from the JE level. Can you believe this? The mechanics question that you're getting in ISRO, I think in 2014 or 2013 in JEE question, the same question was asked. Good afternoon, good afternoon. Okay, so 3v cos theta is the correct answer. Is this clear? Option A. Right, and the basic one, there is no difficult. Now, the next question. A mass of 35 kg is suspended from a weightless bar AB, which is supported by a cable BC and a pin at A as shown in the figure. What is the reaction at point A on the bar AB? That means they are saying what is the value of the horizontal reaction at point A and the horizontal vertical reaction at point A, that is RY A and Rx A. Chalo, quickly, you have to tell me what is the value of horizontal and the this one. So I think this is now diagram is pretty much clear. Let's say this is your Ry and this is Rx. Okay, this is Rx. So if I want to calculate, I'm not taking the reactions at point C, right? If I want to calculate these two reactions, the first method is you can go for the moment about point C. And they have already mentioned that this bar is weightless. The bar is not having any weight. Okay, so the moment about point C equal to 0, I can say Rx into 125 is equal to capital Mg into 275. Yes. So from here I can say Rx is equal to mass is 35 kg. 35 into 9.81 into 275 divided by 125. Can you tell me what is a rough estimate value that we are getting? Rough estimate value. If you want to go for an easy calculation, you can take G equal to 10 and you can near about get, you can eliminate two options in this case. Either it will be in the 700 range or it will be in the 343. If you see clearly, it will be near about to 700 range. So I can simply say this is 355 Newton. I'm taking a round off. Okay. Fine, if you take 10, if you take this as 10, then the calculation will be easier and you'll be getting somewhere in 700 range. So I can say this A and B is not possible. Right? Now, I need to calculate what is the reaction at point A in the Y direction. Can you tell me? Now, for calculating the reaction in the Y direction, how will we be proceeding? Anyone? Naruto, Vinod, yes, World, Jamin, quickly. What will be, how we can calculate? Now we'll be saying, sir, let us take moment about any other point, but if you take moment at any other point, then the reaction at point C will be also been included, right? So what we can do, we can draw the free body of this particular rod. Okay, if I say this is the rod, AB rod, this is the AB rod, AB, right? So we are having Rx in this direction, we are having Ry in this direction, we are having, let's say this is T, so this is T cos theta. In this direction, it will be T cos theta, and in this direction, it will be T sin theta, and this is Mg. So these many forces are acting on the rod. Okay, and we have already calculated what is the value of Rx, that is this one. So let us say this is theta. So I can say tan theta equal to 125 by 275. So can we say your Rx into tan theta is equal to Mg. Can I write it like this? By 275, 125 by 275 is tan theta. So Rx tan theta is equal to Mg. Please note this. This will be helpful in the later on stages. So here I can say Rx is equal to T cos theta, right? So T is equal to Rx by cos theta, right? And here I can say Ry is equal to Mg minus T sin theta. So putting the value of this over here, okay. So I can simply say Ry is equal to Mg minus, instead of T we can say Rx by cos theta into sin theta. What is this? That is tan theta. So Mg minus Rx tan theta. What is this? What is Rx tan theta? We already have seen Rx tan theta is equal to Mg. So this is equal to 0. Okay, so the vertical reaction at point A will be 0. So option D is a correct answer. It's not a difficult question. It is not a calculative also. Only you have to apply slight logic. Please make sure that you keep in mind in this, in the ISRO examination, mechanics do have a good weightage, and if you are solving, if you are calculating the t value, placing it there, it's sheer wastage of time, and definitely the calculator will be it will be long calculation. So try to approach solving these type of question having slight smart approach. Okay, fine. Is this clear? Are we getting option D? Mechanics क्या difficult लग रहा है? Are you getting the mechanics portion slightly difficult? Any difficult नहीं है, it's a very easy one. Only thing, slight understanding. So next question, the very favorite topic, that is stresses. A simple structure A, B, C, D, E is supported on a hinge A and on rollers at B, while it carries a horizontal force of 1000 kilonewton at point E as shown in the figure. What is the force in the member AC? What is the force in the member AC? Quickly tell me. You have to calculate the force in this member. Which method you will be preferring? Write in the comment section. Vinod, Naruto, World, Pagle World. Okay. Yes, Jamin, which method you have to proceed in order to calculate FAC? Don't tell me method of joint, because if you're going for method of joint, it will be a time-taking approach. What we can do is we can go for method of section. We can take a section like this. Okay, and I can eliminate the lower portion. Exactly. Fine. Exactly. Or what we can do is we can eliminate the lower portion like this. Chalo, we can eliminate the lower portion like this. Okay, so I can simply say this is your complete body. This is 1000 kilonewton, right? And this is intersecting 3/4. This one, and this one. Okay, this is FAC. This is theta. This is also theta. So this will be theta. So I can simply say FAC cos theta is equal to 1000 kilonewton, right? So FAC, what will be this theta? 1 and 1, theta is equal to 45 degree. So FAC is equal to 1000 root 2, that is 1414 kilonewton. Simple three line question. Option D is the correct answer. Is this clear? Simple 3-line question. You can take section 3 member, you can also cut, but for easiness, right, I'm taking this 3 segments, 1, 2 and 3. Your members is being cut. Method of section we have to opt, right? Okay, so by cutting this, I'm getting FAC. So FAC cos theta is equal to 1000 kilonewton. So from here, I can clearly say the force in the member FAC is 1414 kilonewton. Is this clear, everyone? Option D. Okay. Yes, everyone. Mechanics में थोड़ा सा practice की जरूरत है. They are saying that use method of joint, but why they are not even going to check that are you using method of joint or method of section? Simple. The main objective is to get the answer. Okay, chaliye, next question on the screen, from the heat transfer. Okay, consider a steady state heat conduction across the thickness in a plain composite wall as shown in the figure, exposed to convection conditions on both sides. The inlet convective heat transfer coefficient is 20, outlet is 50, inlet temperature is 20, outlet temperature is -2 degrees Celsius, K1 and K2 value is 20 and 50, the L1 and L2 is 0.3 and 0.15. You have to tell me what is the interface temperature, let's say this is TIN, if the contact resistance is being neglected. Okay, so I've given the data, I've written the data on the left top corner so that you are not able to have any doubt. So they are asking you what will be the temperature at the interface, TIN. How will you proceeding? If you have attended my yesterday's app class, I've already discussed all these questions. Heat transfer ke previous question we have already taken. Okay, so it's a matter of few minutes you'll be able to get the answer. Now how will be proceeding? This is a series connection. There are 4 resistances, right? We're having 4 resistances. There is a convective resistance over here. There's a conductive resistance over here. Again a conductive resistance and a convective resistance, right? This is your TI. This is your T interface and this is T outlet. This is 20 degrees Celsius and 1 upon HOA. L1 upon K1 into A. This is L2 upon K2 into A, 1 upon HO into A. This is HI, not HO. Right? So we have seen a series connection, 4 resistances, 2 convection, 2 conductive. Try to apply the logic and tell me what is the answer you're getting. Are we getting 0.5 or 2.75 or 3.75 or 4.5? Sir, where can I learn these topics, books? Please give any suggestions. It is being like there are many textbooks. You can go for DS Kumar if you want to have an easy language. DS Kumar. You can go for Senjal, a standard textbooks where mistakes are very less. Right? You can go for Senjal, a standard book for heat transfer. Okay. Very good, Vinod. Very good, very good. So simple. It's a series connection. So same current will be flowing throughout. Same current will be flowing throughout. So let us take 2 on both sides. Like we can say Ti minus T interface. Now from Ti to T interface, there are 2 resistances. That is 1 upon, I'm directly writing the values. Or let us Hi into A plus L1 by K1 into A. That should be equal to from Tin to T out. That is Tin minus T out divided by 1 upon HO into A plus L2 by K2 into A. Placing all the values, your TO value is inlet temperature is 20. So we can say this is 20 minus Tin divided by 1 upon Hi value is 20. 20 into A plus L1 value is 0.3 divided by 20. I think K1 is 20 into A is equal to Tin minus temperature is -2, so minus plus divided by 1 upon HO is 50 into A plus L2 is how much? 0.5 na? L2 is 0.15 by 50 into A, right? So you've written all the values. A will be cancelled out, so we'll be having 20 minus Tin divided by 1.3 divided by 2 is equal to Tin plus 2 divided by 1.15 divided by 5. Okay, so solve it. 40 minus 2 Tin divided by 1.3 is equal to 5 Tin plus 10 divided by 1.15. You solve it, you will be getting slightly 3.75 degrees Celsius, which is, I think, option C is the correct answer. Okay, C is the correct answer, right? Slightly calculative. I do accept that this question requires slight calculation, and please make a very clear note. If you are getting slight calculative, definitely that year you are getting a slightly lesser cutoff. Okay, because without calculator, slightly difficult. You have to do some approximation, and the option, if you try to see the option that you are seeing over here, it's slightly closer, 3.75, 2.75, 4.5. So you have to have a less, like we can say, approximation should be appropriate. Okay, fine. So you're getting option C as a correct answer, 3.75 degrees Celsius. Done. Can we proceed? Because till now, slight calculative. After this inner stretch will be having a very easy questions from heat transfer, from mechanics, all these questions. So next question, a coolant at 30 degrees Celsius flows over a heated flat plate. So we are having a flat plate over which the fluid is flowing, right? It is creating a boundary layer, and the temperature is maintained at 100 degrees Celsius, and the ambient fluid is having at 30 degrees Celsius. They are saying that the at given location on the plate may be approximated as the temperature profile that we are having. In this case, your T is equal to 30 plus 70 e to the power minus y at a distance y from the normal. Okay, so we'll be having something like this. This will be the temperature profile. Okay, so at any distance y, your temperature profile is 30 plus 70 e to the power minus y. The thermal conductivity is of the fluid is 1. What will be the local convective heat transfer coefficient? Can you tell me what is the value of the local convective heat transfer coefficient at a distance x? What will be the value of H? Simple question. We know that at the boundary, at the surface, when y equal to 0, this is y equal to 0, can we say that your whatever heat will be conducted, the same heat will be convected. At the interface, we can say minus K of fluid del T by del Y at Y equal to 0 is equal to Hx into delta T. Right? What is del T by del Y? Del T by del Y will be equal to minus 70 e to power minus Y. So we have to put at Y equal to 0, this is equal to minus 70, right? Fine. So this is minus K value is how much? 1. Minus 70 is equal to Hx. We need to calculate what is the temperature difference. 100 minus 30, 70. So here I can say Hx is equal to 1 watt per meter square Kelvin. Very easy. I don't think so. This is a heavy calculator problem. Okay, option B is the correct answer. It's not a heavy calculative problem. A simple question from the concept of convection heat transfer. Is this clear, everyone? Very good. Vinod, Naruto, Pagal World, data aa gaya. Restore the data. I've seen when I was in the comment section, your data was almost going to finish. So I won't be taking much time, right? So don't worry. Next question. A furnace is constructed as shown in the figure. The interface temperature T1. So let's say this is the interface temperature T1, which we need to calculate. By simple question. Very easy question. Resistance analogy, right? There are two different bodies connected in side to side. There's a series connection. You have to tell me what is the interface temperature. But one thing you have to make sure. Here there are two temperatures being given. One is 120 and second is the ambient temperature. Okay, so tell me which temperature will be taking into consideration while drawing the network diagram. If you see, this is 1000. Perfect. This is 1000 degrees Celsius. 1000 degrees Celsius, right? This is the interface temperature T1. Now, if you see there, this is the ambient temperature. This is the temperature of the outer casing. So I can say this is 120. So you have to take the 120 degrees Celsius. That's it. So simple. Let's try to write 1000 minus T1 divided by 0.3 divided by 3 into A equal to T1 minus 120 divided by 0.3 divided by 0.3 into A. Solve it. So this get cancelled out. A get cancelled out. This is 0.1. So 10,000 minus 10 T1 is equal to T1 minus 120. So 11 T1 is equal to 10120. So T1 is exactly equal to 10120 divided by 11. So approximately 900 something, 990, 900 something, 920 degrees Celsius. Option C. We know, no, it won't be A. Go with a rough calculation. 10,000 divided by 11, somewhere around 900 will be the value. I'm not calculating the exact value, not required, because the range is very distinct. 560, 200, 920, 1120. There's a distinct range, so definitely your option C is the correct answer. Clear hai? Everyone, please do let me know. Yes? Arey Baba, very easy question. Done? Chaliye, next question on the screen from the concept of theory of machine. Chalo, quickly. As shown in the figure, a mass of 100 kg is held between two springs. Okay, two springs we are having, and what is the natural frequency of vibration of the system? So there are two springs. I hope so you are able to see, each having the same stiffness. They are connected in parallel. You have to tell me what is the natural frequency of vibration in cycle per second. That means they are talking about hertz. Okay, they are talking about hertz. Chaliye, very easy question. Very good, very good. So let me draw it over here also, because some students might not be able to see the diagram here easily. So this is the diagram that we are having. Mass M, this is the second spring, 20 kilonewton per meter. This is 20 kilonewton per meter, right? So this is in parallel. So K equivalent will be simply equal to 40 kilonewton per meter. So omega n is equal to under root of K equivalent by M. This is 40 into 10 to the power 3. What's the mass we are having? Mass is 100 kg. 100 kg. So it will be 400, that is 20 radian per second. But in the question, they're asking you in cycles per second, that is hertz they're asking. So frequency is equal to omega n by 2 pi, that is equal to 10 by pi hertz. 10 by pi hertz, option C. Very good. Very good. Option C is the correct answer. Chali, next question on the screen from the concept of heat transfer. Again, a very easy question. Now, if you remember, 2 years back in ESC, there was only two questions. I already told you that in ESC prelims, from heat transfer, only two questions. one from this critical radius of insulation, second from the boiling and condensation. Okay, so let's see, for a wire current of 20 mm diameter exposed to air, H is equal to 20 watt per meter square Kelvin. For maximum heat dissipation occurs when the thickness of insulation is, they are saying for maximum heat transfer, what should be the thickness of insulation? Quickly tell me. This is, I'm talking for a wire, cylinder. Option A, option B, option C, or option D. This is the wire that we are talking about. K by H. Dekho. Many students are committing the mistake. They are saying the thickness of insulation. Let's say what is RC? RC is equal to K by H. K is equal to 0.5 by 20. That is 25 mm. This is the radius of insulation. They are not asking you radius of insulation. They are asking you what is the thickness of insulation. Let us suppose if I want to have maximum heat transfer, your radius should be 25. So what should be the thickness? 25 minus 10, that is 15 mm. Option D is the correct answer. Option D is the correct. This is the mistake students do in this particular segment. Okay, question is very easy. Only thing you have to understand is how to get the correct answer. Okay, sometimes in a hurry when they calculate RC, they see, oh, 25 mm is there, let us mark option B and move forward, which is incorrect. Okay, please make sure read the question carefully. These are some silly mistakes students do in the examination. So these practice will be helping you to overcome these mistakes. Okay, chali, next question. Again the same problem, same year, back to back two question, heat transfer, same topic. It is proposed to coat a 1 mm diameter wire with an enamel paint of 0.1 watt per meter Kelvin to increase the heat transfer with air. The air side heat transfer coefficient is 100 watt per meter square Kelvin. What is the optimum thickness? Again the same problem. Please make sure you are not committing the same mistake now. Okay. Whenever you are having a question from this, draw a small diagram. This is the wire and always write in terms of radius. So they are talking 1 mm diameter, that is 0.5 mm radius. Okay. So RC will be equal to K by H because this is a wire. 0.1 divided by 100, that is 1 mm. Okay, fine. That means for maximum heat transfer, your radius of insulation should be 1 mm. So let us try to have this one. This total should be 1 mm. So definitely the thickness of insulation should be 0.5. That's it. Option B is the correct answer. Okay, whatever mistake you can do, that mistake option, the wrong option is there in the other options. Okay, whatever silly mistakes you might be doing, that value will be available in the options. So make sure you are careful in ISRO examination. Right? Option B, 0.5 is the correct answer. Let us proceed with the next one. In a pulverized fuel fired large power boiler, the heat transfer from burning fuel to the walls of the furnace is by conduction only, by convection only, by conduction and convection, predominantly by radiation. Simple question. If I say there's a huge large fire power boiler, okay, we're having a pulverized fuel fired large power boiler, we know that at high temperatures radiation is dominant over conduction and convection. If I say at higher temperatures, because the emissions that we are having in radiation, right, we are having the emissions, MEC power is divided to fourth power. Okay, exactly, very good. Chandra sir is also in the comment section. I'll be giving the command to sir in within 5 minutes, but I want you guys to respond as soon as possible, right? So we know that radiation is at very high, that at high temperature radiation is predominant over conduction convection. So I can see option D is the correct answer for power boiler, large power boiler fired fuel fired power boiler, because we are talking about a very high temperature at near about a range of 1000, 1500 or 2000 degrees Celsius. At that range radiation is predominant over other modes of heat transfer. Option D is the correct answer. Okay, chale, next question. Three metal walls of same cross section having an area, the cross section area is same, thermal conductivity is in the ratio of K1 is to K2 is to K3 is equal to 1 is to 2 is to 4, and the rate of heat transfer is 6000 kilojoule per hour. For same wall thickness, what is the temperature drop? Quickly, simple question from the concept of Fourier heat transfer. Most probably CBT, most probably CBT, right? But hope that we are having CBT only. Okay. Yes, everyone. Because they have not mentioned about the type of paper, right? But normally, if considering the last 2 years, it was CBT only, right? So we can expect CBT only. See, very good. Now they say that what is the Fourier's law? Q is equal to K into A into delta T by L. Same wall thickness, right? Area is same heat will be flowing. Can we say the temperature difference is inversely proportional to K? For same Q, A and the thickness, temperature drop is inversely proportional to K. So I can say that is 1 is to 1 by 2 is to 1 by 4. Option B is the correct answer. 1 is to 1 by 2 is to 1 by 4. That's, we have to take the opposite of that. Okay, fine. Right, before COVID situation. But now we can expect CBT because majority of the PSU examination are conducted by CBT only, right? So we can have a 80-20% chances, 80% for CBT, but if I say they are conducted offline, then there are some possibility also because it's not being clearly mentioned, right? Right, so option B is the correct answer. 1 is to 1 by 2 is to 1 by 4. Is this clear, everyone, in the comment section? Option C is incorrect. Option C is incorrect. Simple question, right? Okay, next, can we proceed? Vinod, Naruto, Jamin. Yes, next question. A drawing which shows the product with its components in their correct physical relationship is called. They are saying which of the drawing tells us about the product with its component. Are we talking about part drawing? Are we talking about layout drawing? Are we talking about assembly drawing or fabrication drawing? If I say product with their components, so definitely we are talking about the assembly drawing, right? We are talking about the assembly drawing because in assembly only I need to see what product and which components need to be attached, right? Part drawing is different. Part drawing is each and every component will be having the detailed description. Layout is the entire layout in which different machineries will be there. Fabrication drawing is one part, what's the dimension, just like a bill of material. Okay, what are the dimension, which material we are using, that is a different one, right? So option C is the correct answer. Now let's take few questions from mathematics, and after that, Chandra sir, off to you. 5 minutes, sir, not more than that. For the matrix 4, 1, 1, 4, what are the eigenvalues we are having? Quickly, you have to calculate the eigenvalue. So let us suppose the eigenvalues are lambda 1 and lambda 2. So considering this, we can say lambda 1 plus lambda 2 is equal to 4 plus 4, that is 8, and lambda 1 into lambda 2 will be the determinant value, that is 16 minus 1, that is 15, right? So I can say that your lambda 8 minus lambda 2 into lambda 2 is equal to 15. So this is 8 lambda 2 minus lambda 2 square is equal to 15. Simple question, simple question. Plus you have to make it 8. So only one option is there, that is option C. Definitely no need to solve, but for easiness I'm going for that. Delta square minus 8 lambda 2 plus 15 equal to 0, right? So we are having lambda 2 minus 5 into lambda 2 minus 3 equal to 0. So lambda 2 is equal to 5 comma 3. So lambda 1 it will be equal to 3 comma 5. So option C is the correct answer. That's it. Option C is the correct answer. Okay, clear? Fine. Done. So next question. The solution for the following differentiable equation with the boundary conditions y0 to y1 equal to minus 3. They have given the second order differential equation del 2y by del x square is equal to 3x minus 2. So what is the equation of y? What is the function of y we are having? What is the equation that we will be getting? Simple. Let's try to integrate one time. So del y by del x is equal to 3 by 2x square minus 2x plus c1. I can differentiate y is equal to 3x cube by 2 into this 3 and 3 will be cancelled out. So this will be x cube by 2 minus x square plus c1x plus c2, right? So if you try to see x cube by 2, there is only one option. Option C is the correct answer. Only one option. No need to check, no need to calculate the integrated question C1 and C2 values, but let us try to solve it. When you put x equal to 0, you're getting y equal to 2. So if you put x equal to 0, that means your C2 is equal to 2, right? Fine. So your equation will be y is equal to x cube by 2 minus x square plus C1x plus 2. Second boundary condition is when you're putting x equal to 1, y is equal to minus 3. So x equal to 1, we can place it over here. Minus 3. Minus 3 is equal to 1 by 2 minus 1 plus C1 plus 2, right? So solving, you're getting C1 is equal to, this is minus 1 by 2, this is 1.5. So 3 minus 4.5. Okay, that is 9 by 2 minus 9 by 2. So option C is the correct answer. Okay, so you're getting the final expression as y is equal to x cube by 2 minus x square plus minus 9 by 2x plus 2. Clear hai? Yes. Next question, the last one. Last question. Which of the following, for which value of x the matrix this will become singular? What is the condition for singular matrix? What is the condition for singular matrix? The determinant will be equal to 0. Let us say this is matrix A. So I can simply say the determinant value should be equal to 0. That is the condition for singular matrix. So let us calculate 8 into 0 minus 12 minus x into 0 minus this will be 24 plus 0 into 24 minus 0. So this becomes minus 96 plus 24x equal to 0. So x is equal to 96 by 24. So this is 4, x equal to 4. Option A is the correct answer. Option A is the correct answer. Okay, fine. Is this clear? So this is it from my side, and this is all the questions from the heat transfer, industrial, theory of machine, your mechanics and the mathematics part. So I'll be uploading the combined PDF on my Telegram channel, that is Mechanical by Suraj, and we are having the free ebooks. One of the students has asked about, sir, where we can download the free ebooks. It's there in the comment section, in the description box, and along with that the scholarship test link and the workshop test link, both is in the description box. Okay, so this is it from my side. So over to Chandra sir. I hope you all enjoyed. Do not leave the session. Chandra sir will be taking very important question from fluid mechanics and thermal and applied. Very good important questions. So over to sir, and please do let me know if you're having doubt or no. Okay, and if you have any doubt, please write in the comment section. Okay, I'll be sharing that in the comment section, right? So over to Chandra sir. That's it from my side. Thank you. Bye bye.
Hello everyone, a very good afternoon all of you, and a very warm welcome to you all to this beautiful session, that is ISRO 2015 question paper we are discussing. So please guys do let me know if I am audible and visible to everyone. Can you guys hear me? So I will not take more than 30 minutes. I am having around 19 questions. Few questions from the fluid mechanics and some of the questions are from the thermal. Let me tell you, in 2015, the basic thermodynamics was more important. More number of questions were asked from the basic thermodynamics rather than the application. But in fluid mechanics, there were questions from the machinery part as well. So please guys do let me know if I am audible and visible to everyone. Hi Naruto, Vinod, Abhishek, welcome guys, welcome. Let us start without any delay. So for the next 30 minutes, please be there with your full dedication, with your full enthusiasm. This is my quick introduction for those who are seeing me for the very first time. Mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience, also cleared engineering services examination. Shall we start? You can always connect with me through the mail ID and join me on the Telegram, that is Mechanical by Chandrasekhar. Once you become part of my Telegram group, then we will be sharing the PDF of this session as well, and we will be having the doubt clearance also through the Telegram group. Please do keep your notebook and pen and try to solve the question with minimum time and with maximum accuracy without using the calculator. You must be aware about the scholarship test. Tomorrow there will be scholarship test starting at 12. So please do register yourself, and for registration the link is already there in the description box. All right. So let us start with question number 1. The question is very simple. I want you guys to give me the answer for this question. Please do let me know your answer. When a floating body is given small angular displacement, it starts oscillating about. This is warm-up question. What is the answer? It starts oscillating about which point? It starts oscillating about the point called meta-center, isn't it? The point is called as meta-center. Meta-center is the point about which a floating body oscillates. And if the meta-center lying above center of gravity, then it is the stable equilibrium. It is in stable equilibrium, right? Hi Naruto, yes, well done. New HD movies, good, good. The next question is again very simple. From the fluid mechanics, Bernoulli equation is applied to. What is the answer? Yes, Vinod, well done. Every one of you, please give me the answer for question number 2 quickly. These are theoretical and simple questions. So you should not take much time in getting the right answer for these type of question. Yes, Abdul. Bernoulli equation, these are all the equipments utilizing the Bernoulli principle. Venturimeter, orifice meter and pitot tube. Every instrument is using the Bernoulli equation. So the correct answer, sometimes what happens is, students are in so much hurry, they try to save time, they try to utilize as minimum time as possible. So by seeing the first option, that is venturimeter, they do not feel the need of seeing the other options. Then they tick the option A. That mistake you should never commit. Always observe all the options, and the one which you feel to be most correct will be your answer, should be your answer, right? D is the answer. चौरसिया जी ने यही गलती की ना. It is not A, it is all. The next question. A jet of water discharging from a 40 mm diameter orifice has minimum area at its vena contracta. Because of sudden convergence through the orifice meter, there the streamlines will keep on converging. That point is called as vena contracta when the convergence is maximum or the area at the vena contracta is minimum. Due to sudden convergence, there is a losses occurring. Due to sudden change in area, there are losses, and that losses are accompanied by the coefficient of contraction. The value of coefficient of contraction lies between 0.1 to 0.65. And in case of pitot tube, we define coefficient of velocity, that is around 0.96 to 0.99. And coefficient of discharge for orifice meter is around 0.61 to 0.69 something. So it is about the coefficient of contraction, then it is 0.61, isn't it? 0.61. This is the memory based question. ISRO asked the question based on memory as well. Again, numerical can also be framed from this question, but the question is theoretical, whether you remember the direct formula or not. What is the answer to this one? The time required to empty the tank. So the time will be calculated by using the mass conservation or mass balance. The mass of the liquid leaving from the orifice in small time dt will be equal to change in mass in the tank. So if we do the integration, then we will get 2a under root of h1 minus under root of h2 upon cd into area into root 2g. Capital A is the area of the tank, small a is the area of orifice. If we want to completely empty the tank, then h2 becomes 0. Completely emptying the tank means h2 will become 0. h2 should be 0. So the answer to this question will be, what is the answer? Can you let me know the answer? Yes? Isn't it option? No, it is not B. You forgot under root. 2a root h1 minus root h2 विनोद देख रहा है विनोद कहां गलती होती है you should learn from your mistakes these silly mistakes theoretical question or the formula based questions you should never commit mistake otherwise you will not be able to compete with your competitors right so option A will be the right answer for this one I hope this is clear. This is the standard formula you can memorize. Numerical can also be framed. In 2023, I am feeling that there will be a numerical problem based on this formula. In 2015, mostly standard results. Questions were asked from the basic standard results. So you should revise your subjects thoroughly and whatever the important results you are having, you are developing, you should memorize those important results. Nobody is going to ask you to derive those results and you do not have time to derive the results. If you know the standard results, then only you will be able to save some time. What is the answer? The power transmitted through the nozzle is maximum when the head loss due to friction in the pipe is minimum. What is the power? Power is rho Q G H minus HL. This is the power transmission. So power will be maximum if HL should be minimum. And what is the minimum value of HL? H by 3. If you differentiate and put it as 0, you will get the condition for maximum power transmission, H by 3. So it is 1/3 of total supply head, right? Yes, Abdul, well done. Naruto, good, good, good. What about others? I want everyone to keep responding. If I will solve each and every question here, then you may develop pseudo confidence, and that is very dangerous in competitive examination like ISRO. So when you will do it on your own, then only you will develop the positive confidence, and even if you commit mistake, you can learn from your own mistakes. What is the next question? Answer to the next one. Again, theoretical question, question number 6. Yes. What is the type of flow when a cylindrical vessel containing some liquid is rotated? The rotation is due to by external means. What is that? There are two types of vortex motion. It is vortex. There are two types of vortex. One is free as another is forced. Because it is rotated about some axis, that is called as forced vortex. It is actually forced vortex. It is not the free vortex. In case of forced vortex, V is equal to R into omega. Tangential velocity is directly proportional to R. I hope you know that. Tangential velocity will be directly proportional to R. So these were the theoretical questions. Let us move to some numerical questions which have the challenge to solve them without using calculator in ISRO exam, right? So on 30th of June, do not forget to join this workshop taken by Abhinav Negi sir, and you can register yourself to the workshop, and do let me know what kind of sessions you require from our end to boost up your preparation for the ISRO exam. What type of sessions you want? So we will definitely plan the type of session as per your requirement in the near future. So you can just let us know, help us out to make the proper study plan for you guys so that you clear the examination with flying colors. The next question is numerical again from the fluid mechanics. Water at 25 degrees Celsius is flowing through a 1 kilometer. People commit mistake in units as well. That length of the pipe is 1 kilometer, 200 mm diameter. Diameter is in mm. At the rate of 0.07 meter cube per second, that is the discharge. If the value of Darcy friction factor, sometimes the friction coefficient is also given. If the friction coefficient is given, do not forget to multiply by 4. The Darcy friction factor for this pipe, that is F, is given as 0.02, and the density of water we all know. The pumping power required to maintain the flow, that is nothing but power loss. The pumping power required is nothing but the loss in power. The one who will get me the right answer for this question without using the calculator will get a chocolate. Let me see who will be the chocolate winner. HL is equal to, or we can say, power loss is equal to rho into Q into G into HL, and HL can be written by using Darcy-Weisbach equation. So rho into Q into G into FL Q square. Let me use discharge only. Q square upon 12.1 D to the power 5, isn't it? So it will be rho is 10 to the power 3. Q is, it is Q cube. So Q is 0.07 cube into G, let me take as 10, into F, friction factor is 0.02, and into 10 to the power 3 is the length. I am using all the parameter in the SI unit. 12.1, the diameter is 200 mm, that is 0.2 to the power 5. This will give you the power loss in watt. If we want in kilowatt, this is in watt. If we want in kilowatt, remove 1 10 to the power 3. So it will be 10 to the power 3 plus 10, 10 to the power 4 minus 2. So 10 to the power 2 into 7 cube into 10 to the power minus 6, isn't it? Into 2 upon 12.1 into 2 to the power 5 into 10 to the power minus 5. Do you understand it or not? Do you get it or not? What is the answer? So 10 to the power 2 into 10 to the power, so this 2 will become 10 to the power 2 to the power 4. So can we call it as 10 to the power minus 4 plus 5? That is 10 into, what is 7 into 7 into 7? 343, isn't it? Divide by 12.1 into 2 to the power 4, that is 16. Isn't it? Can you calculate now? Can you calculate? Can you find out the nearest option? Can you find it out? Yes? Can you get me the answer? So it is less than 343 by 16. It is less than 343 by 16. What is 343 by 16? It is less than 21. Can you find out the answer? It should be around 17.4. Are you getting 17.4? Are you guys getting 17.4? B is the answer. B will be the answer. 17.4. I think it will be 17.71 something. It will be 17.7. But because we have taken G as 10, that is why we are not getting the exact answer. So it is almost 17.7. So 17.4 will be the right answer for this one. I hope this is how you should understand that without calculator you can get the right answer. The velocity at which the laminar flow stops is known as, what that velocity is called as? What is the answer to this one? The velocity at which laminar flow stops is called as lower critical velocity. There are two velocities, Reynolds number less than when the Reynolds number less than 2000, less than equal to 2000, then the flow is laminar. When the laminar flow stops, that will give the critical velocity or the lower critical velocity. When the Reynolds number is greater than 4000, the flow becomes turbulent. So that will give the higher critical velocity when the flow actually start becoming the turbulent flow. That will give higher critical velocity when Reynolds number is 4000, and when the Reynolds number is 2000, that will give you the lower critical velocity. The next question is from the basic thermodynamics. Yes, Vinod, Naruto, well done guys. I want all of others also. Please keep on responding through the comment section. I will take not more than 30 minutes, provided your participation is must. The difference between two specific heats, Cp minus Cv is equal to R by J. Cp minus Cv is equal to R, or we can say R bar by M. That is valid for only perfect gases. This is valid only for perfect gases. Only ideal gas. This relation is applicable to ideal gas only. The answer will be option B. B will be the correct answer. Basic question. This question is actually beautiful. Sometimes you may find that conceptual question which you have never seen in any other exam. Yes, I invite all of you to give me the answer for this question. We are almost halfway now. A process in which no heat is supplied, Q is equal to 0 or rejected from the system, and entropy is not constant. Students, because of the examination pressure, they may not see this not term and they may think it as isentropic. It is not an isentropic. When the entropy remains constant, then it is called as isentropic. Because the entropy is not constant, it is not isentropic. So when entropy changes, then definitely temperature changes. The temperature changes because of work transfer. There is no heat transfer, but the temperature can change because of the work transfer also. So if the temperature changes, it cannot be isothermal. So the process is polytropic. C is the answer. It is a polytropic process. It is neither isothermal nor isentropic. Hyperbolic, there is nothing called hyperbolic. That option D is just to make 4 options. Otherwise, you must see the difference between isothermal, isentropic and polytropic. So the correct answer is option number C. No, Vinod, D nahi hoga. Hyperbolic, there is no process. There is no thermodynamic process called hyperbolic. Okay, so there is a special series going to be started on YouTube as well as the app. And the best part of this series is this is the war between mechanical and civil. And I want you guys to be in large number to these sessions for helping the mechanical team to win. And the top students will get surprise gift hamper as well. The series will be starting from, there is nothing mentioned, 14th of June. The series is going to be started from 14th of June. Thank you, Chaurasia. We are trying our level best to make the understanding simple, interesting, so that you boost up your confidence and at the same time you learn the concepts. So we are trying to make your learning to be joyful, interesting and result oriented. That is our agenda, and if you are ready to do the hard work, then nobody can beat this combination. Your hard work and our guidance, you will definitely get the success in your exam. Carnot cycle is having the maximum efficiency for which one? Carnot cycle is having the maximum efficiency for which one? Quickly, all of you. We are halfway. I am having the next 9 question or 8 questions only. This is question number 11. 8 more questions to go. I will not take much of your time, precious time. But please, if you are here, if you are sitting in front of your laptop, if you are attending the session, then try to gain maximum benefit out of this session, because your time is precious, your energy, your positivity is very, very important in getting the maximum benefit out of this session. It is for reversible engine. Everybody knows, even a small child knows that the Carnot cycle is having the maximum efficiency. This is the question again from steady flow energy equation. But in steady flow energy equation, the problem is people commit mistake in units because the velocities are taken in meter per second, whereas the enthalpies are taken in kilojoule per kg, specific enthalpy. You should not commit those type of mistakes. So the question says, what will be the power output of the turbine in megawatt? So if you write steady flow energy equation, everybody knows the question. The beauty of ISRO exam is the questions are asked which are using the standard formula, those formula which are important. So we can say H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. And then heat transfer is 0. It is thermally insulated. Is it thermally insulated? The inlet and outlet condition for steam for adiabatic steam turbine, it means Q is equal to 0. It is thermally insulated. So if Q is equal to 0, the question is to find out W. So what we can say, if we want to write in kilojoule per kg, then we will say H1 minus H2 plus 1 by, it will be 2000 C1 square minus C2 square plus G into Z1 minus Z2 in kilojoule per kg. Do not forget that it must be in kilojoule per kg, isn't it? Isn't it? So here also it will be divided by 2000, isn't it? Here also it will be divided by 2000. Do you get it or not? Do you agree or not? GZ will also be divided by 2000. Is it correct or not? So W is equal to what is H1 minus H2? 3200 minus 2600 plus 1 by 2000. Then what is C1 square? C1 is the velocity V1 160 square minus 100 square plus G is, let us say, 10 by 2000. Z1 minus Z2 in meter. 10 minus 6. Did I write it correctly? Sorry, yes, it will be divided by 1000. That is what I wanted from you. Yes, we know the others have not responded. It means they are not aware. So 3200 minus 2600, the unit is kilojoule per kg. So it will be 600 plus 1 upon 2000 into 160 plus 100 into 160 minus 100. Isn't it? Then it will be 1 by 100 into 4. So if you see, and if we want the power in power output, if we want power output in kilojoule per kg or kilowatt, so we will write m dot, that is 20 into 600 plus how much is that? 1 by 2000 into 260 into 60 plus 4 by 100. And if we want in megawatt, let us first find out in kilowatt. So it will be 20 into 600 plus, it will be this getting cancelled out, this getting cancelled out, 2 3 are 6. So 26 into 3, 78, it will be 7.8, isn't it? 7.8 plus it will be 0.04, right? So the answer will be 20 into how much is that? 607.84. 607.84, isn't it? Is this correct or not? $607.84 multiplied by 20. So what you need to do is you should multiply 60.784 into 2. 60.784 into 2, it is in kilowatt. And if we want to convert it into megawatt, then we will write 0.06 into 2 something in megawatt. Sorry, in megawatt. Yes, where I committed the mistake. 20 into 6 Okay, then it will be, sorry, 6078. It will be 6078.4. 6078.4 into 2, that is in kilowatt, right? In megawatt it will be 6.0784 into 2 megawatt. That is the power developed. So what is 6.07? 12.14 something, isn't it? It is 12.14 megawatt. 12.14, 12.157 is the correct answer. 12.157. Are you getting it or not? Option A will be the right answer. I hope this is clear. I am solving this without using the calculator. The next question on your screen. How many of you got the right answer? Nobody? किसी ने भी नहीं बताया option A? Nobody had given me the answer as option A. Why? That art you should learn. Cracking an examination requires an art. A solar energy based heat engine, it is about a heat engine, or it is about the second law of thermodynamics, which receives 80 kilojoule of heat, 80 kilojoule, that is Q1 of heat at 100 degrees Celsius, and rejects 70 kilojoule of heat to the sink, that is Q2, is to be designed. The thermal efficiency, it is very simple. Work output will be equal to 10 kilojoule, isn't it? So what is the thermal efficiency? That is W by Q1, 10 upon 80, 1 by 8 will be the answer. What is 1 by 8? What is the answer? Isn't it 12.5? Is it 12.5? 1 by 8? How much is that? Isn't it 12.5? Are you guys getting the answer or not? Why you are not responding? Option C. The challenge for you is to solve the question before I solve it on the screen. The next question. Question number 14. I am having total 19 questions. 5 more questions to go. We will stop before 2:30. A Carnot cycle. Here it is a Carnot cycle. It means reversible. A Carnot cycle refrigerator operates between 250 Kelvin and 300 Kelvin. So it is 300. That is the refrigerator. It is a refrigerator. It is not a heat engine. So Q1 and then this is Q2 W. And this is 250. The cold storage space is at 250 Kelvin. This is at 300. T1 is 300. T2 is this. What is the coefficient of performance? COP is the equal to Q2, the desired output upon work input. Or we can say Q2 upon Q1 minus Q2. And if it is a reversible refrigerator, then it will be in terms of temperatures. So T2 upon T1 minus T2, what is the value? T2 is 250 upon 300 minus 250, that is 50. 250 upon 50, that is 5 will be the answer. B is the answer. Yes, BB. Yes, Vinod. If you are beginner others, then you should revise the concept. Do not practice much numericals. It is always better if you want to appear for ISRO exam, do have the notes, study notes, do arrange the study notes from somebody, some student or from some institute, and try to revise the important topics. The topics which are important, the subjects which are important are thermal engineering, fluid mechanics, and strength of materials. The basic subjects you should cover first, right? So this should be the strategy. Next is beautiful question. The question is from a diesel cycle, diesel engine. A large diesel engine runs on a stroke cycle at 200 rpm. This is revolution per minute. The engine has a displacement of 25 liter. That is volume. That is A into L. Volume is equal to 25 liter, and the brake mean effective pressure is 0.6 mega Newton per meter square. It consumes this much of fuel. Calorific value of fuel is given as 42,000 kilojoule per kg. Determine the brake power. So brake power is actually torque into omega or torque into 2 pi n by 60. But in terms of mean effective pressure, we can say brake power is equal to mean brake effective pressure multiplied by ALN by 60. Like indicated power, like we write indicated power, mean effective pressure into ALN by 60. Here there is a catch. For a two-stroke engine, that is petrol engine or diesel, petrol engine can be of two-stroke or four-stroke. For a two-stroke engine, one stroke is equal to, for two-stroke engine we can say N RPM is equal to N cycle per minute, and for four-stroke engine, that is the diesel engine, N RPM implies N by 2 cycles per minute. So because it is a four-stroke, diesel engine in a four-stroke, so we will multiply by N by 2 also. So put the value, AL is the volume, A into L is the volume. If you put the values, you will get the answer. So mean effective pressure is 0.6 meganewton. Convert it into kilonewton because the options are in kilowatt. We want the answer in kilowatt. So 0.6 into 10 to the power 3. Can we write it as 600 into what is the volume? 25 into 10 to the power minus 3, isn't it? Into N 2000 upon 60 into 2. What is the answer? That is the brake power. This will give you the brake power. Can you solve it? This 10 to the power 3 will get cancelled out with this. 2 is getting cancelled out with this 2. So it will be 60 will become 10. So it will be 250 kilowatt. The brake power will be 250 kilowatt. Option A is the right answer for this one. Isn't it option A? Do you guys get it or not? Do not forget to divide by 2 for four-stroke engine. The next question. The next two questions are theoretical. The next two questions will be theoretical, and then I will complete the ISRO 2015 previous year question paper successfully. The next question. A gas having a negative Joule-Thomson effect. The Joule-Thomson coefficient is very, very important. There are two parameters which are very important. One is compressibility factor for an ideal gas and Joule-Thomson effect for throttling. You may find question from the Joule-Thomson coefficient. What is del T by del P at constant enthalpy? Throttling process. If it is negative, this is the slope of, what is Joule-Thomson coefficient? Slope of TP curve for isenthalpic process. Throttling process is isenthalpic. So if it is negative, if the slope is negative, if dt by dp at isenthalpic is negative, then what is the meaning of that? It means as the pressure increases, temperature will decrease, or if the pressure will decrease, temperature will increase, isn't it? And because the throttling process is having reduction in pressure, throttling implies the pressure will reduce due to throttling. Throttling is flow through a restricted passage. If the process is throttling, then pressure will decrease, and if pressure will decrease, definitely the temperature will increase. It will become warmer, isn't it? Right? I know it will become warmer. Temperature will increase. If it is positive, if the Joule-Thomson coefficient is positive, then by decreasing the pressure, temperature will also decrease. It will become cooler. But because it is a negative, Joule-Thomson coefficient is negative, that is why it will become warmer. The next question, the pressure, this is the question number actually 17. Question number 17. This question was asked in ISRO 2018 also. We have already discussed the pressure of an ideal gas and its mean kinetic energy per unit volume. So what is the mean kinetic energy of an ideal gas? That is 3 by 2 PV. You should memorize this fact. So mean kinetic energy per unit volume, that is equal to E is equal to 3 by 2P, and P is equal to 2E by 3 will be the answer. Question number 17, option D. Yes, Vinod, you remember. This is beautiful. Now, can anybody let me know? Now, I will invite all of you to give your opinion about this question. Did you guys observe this fact or not first? First, try to let me know. Have you ever observed this? Whenever you put your finger on an ice tray, which is just taken out from the refrigerator, what happens is your finger stick to the ice tray, isn't it? When you put your tongue, when you will put your tongue to the ice tray, just after taking out from the refrigerator, your tongue will stick to the ice tray, isn't it? Your tongue will stick. So which factor has more effect on this phenomena? Which factor will have more effect on this phenomena? Can you just let me know? This is question number 18. One more question after this, then it will be over. The ice tray which is just taken out from the refrigerator, then it is at very low temperature. Very low temperature. When the finger is attached to it, then what will happen? The heat will start flowing from high temperature to low temperature. The heat will start flowing from the finger to the ice, and there is a melting of ice will take place at the surface. Some of the ice will melt into water, and because the ice is having very low temperature, then the water film will again become ice. The water film will again become ice. So that is the conduction. The mode of heat transfer is conduction. So the water film will again become ice because of very low temperature of the ice tray. So the icy bond stick to the bonding, that is the icy bonding which makes the finger stick to the ice tray. So it is the thermal conductivity of the tray. It is the thermal conductivity of the tray, because the mode of heat transfer is conduction. It is the thermal conductivity of the tray which makes the finger to stick on the ice tray once the ice tray is just taken out from the refrigerator. Again, beautiful question. The last one. These type of questions are asked in interviews also. Such type of question can be expected in interviews. Can you get me the answer? This is the last question from my side, and then I will be signing off and see you in the next paper 2014 on the coming weekend, right? Wet clothes are hung on a clothes line outdoors in sub-zero weather, low temperature. After a day, the clothes are brought into the house. House is warm and observed to be dry. The process of drying is best explained as: when the clothes are taken in the room, then the water in the clothes will become dry. They will freeze. The water will freeze, and due to the difference in the room temperature and the cloth, then this ice, the freezing water will directly become vapor. The freezing water will become into vapor. So that process is called as sublimation, the direct conversion of ice into vapor. The conversion of ice into vapor is called as sublimation. Solid into vapor is called as sublimation. So why it appears to be dry? Because all the ice which is on the cloth convert into vapor directly without skipping the water stage, that is called as sublimation. This is conversion of solid ice into vapor directly is called as sublimation. It is sublimation. The process is sublimation. You can find these type of conceptual question in your exam. So be ready for these type of questions. This is all from my side, guys. Thank you very much for joining in, and thank you very much for staying till the end of the session. It started at 12 and it is more than 2:30 right away. So thank you for your patience and thank you for your motivation, energy. I hope you guys thoroughly enjoyed it. Please do not forget to like and share, and we will share the PDF of all the previous session as well as this session very soon on our respective Telegram channels. So if you are not part of my Telegram channel, please do join me on the Telegram. And now let me take your leave. See you in the next session. Till then, enjoy, take care, have a good day and a great weekend ahead. Thank you guys. Thank you very much. Jai Hind.